In this video, I'm going to solve this question. If a machine is correctly set up, it will produce 90% acceptable items. If it is incorrectly set up, it will produce 30% acceptable items. Past experience shows that 80% of setups are correctly done. If after a certain setup, the first item produced is acceptable, what is the probability that the machine is correctly set up? Okay, so there is a lot of information given in this question. So first, let's take some notations. So C is the event that machine is correctly set up. So it's written over here that if a machine is correctly set up, so I'm calling this event C. Then C prime is the event that machine is incorrectly set up. Okay, so it's written over here. If it is incorrectly set up, I'm calling this event C prime. It's not necessary that you have to work with the same notations. If you want, you can also call it C bar or maybe something else. Okay, and then I'm defining A as the event that we have acceptable items. Okay, so these are the three notations that I'm introducing. Now let's see what is the information that's given to us. We are given if a machine is correctly set up, it will produce 90% acceptable items. That means if it's given to us that the setup is right, then it will produce 90% acceptable items. So this means probability of producing acceptable items, given that the machine is correctly set up, this is equal to 0.90. Okay. And then after that we have if it is incorrectly set up, it will produce 30% acceptable items. That means the probability of producing acceptable items, given that the machine is incorrectly set up, and the notation that we have for incorrectly set up is C prime. So this is equal to 0.30. Past experience shows that 80% of the setups are correctly done. That means the probability of C, that the machine is correctly set up, this is equal to 0.80, and this automatically implies that the probability of C prime, that is the probability that machine is incorrectly set up, this is equal to 1 minus 0.80, and this is equal to 0.20. Okay, so this is the information that we have. It's given over here. If after a certain setup the first item produced is acceptable, what is the probability that the machine is correctly set up? Basically, we have to find the probability that the machine is correctly set up, given that we have got an acceptable item. Okay, so this is what we have to find. We have to find the probability of the event C, given that event A has already happened. Well, this is a classic Bayes theorem question, and over here we can just directly apply the Bayes rule. So as you can see, I have written Bayes rule over here. So probability of C given A, this is equal to this using Bayes rule, and we have all this information that we have to put in this formula. So we know probability of A given C, it is equal to 0.90, it's over here. We know probability of C, it is equal to 0.80. This is the numerator. Then in the denominator, this part remains the same as the numerator, right? And then we have plus this part. Now in the second part over here, we have probability of A given C prime. So this is C prime. We already know this is 0.30, and then this is multiplied by probability of C prime, which is 0.20. Okay, now note that probability of C prime was not given directly in the question, but they gave us information related to probability of C. So it was quite easy to figure out the probability of C prime. Okay, so probability of C prime is equal to 0.20. So ultimately we have all the information that we need to work with this formula, and once you put these numbers, you will find that the probability of C given A is equal to 0.9230, and this is the answer.